all of it tomorrow, all of the midterm review. We're just going to review today so we can play a game tomorrow. You need a pencil and a highlighter. Remember that your midterm review needs to be completed. Even if you got like a 0 on a section, you have to go back and fix it and do it so that you can get a 100 on a quiz grade. You're going to turn it in to your whoever teacher yours is when you go to H16. Who is that, Miss? Miss Dix is not teaching you. I don't know. Whoever's in there, you're going to hand it in for your quiz grade. Take your midterm. The paper that you have right now, we're going to go through it. It has all of the properties, all of the formulas you need to remember, and it's really just to help you. Some people like practicing the problems over and over again, like on the midterm review. Some people would prefer this study guide where it just has a bunch of properties that you read. So we're going to do this today, play a game tomorrow. So let's talk about inequalities. An inequality looks like a less than a number, or it could look like greater than a number, or even or equal to, and you graph it on a number line that looks like this. So when you graph on a number line, you're going to put a dot. It's either going to be open or closed. Does anybody remember when it is open?
Whenever it doesn't have a, it's not equal to.
It's not or equal to, right? But if it's or equal to, you close the dot. All right, the next blank, if you multiply or divide both sides, and then you're going to cross out the word then because it matters. Both sides by what?
A negative.
By a negative. So if you multiply or divide both sides by a negative, then what do? Be confident. Flip what? Flip the sign. So less than become greater than become less than, all that stuff. So we're going to graph. Go ahead and put a number line. I do ask that you put 3 numbers on the number line. I'll put 5 in the middle. So we're going to do 4, 5, 6. What kind of dot will I have? Open or closed? Open and shade. In the direction of the arrow, as long as X is on the left, you can shade in the direction of the arrow. If X is on the right, you need to flip it to shade in the direction of the arrow. We're going to see that here on number 2. Is X on the right side of the inequality? It is not. So we're going to flip it around so that we can graph in the direction of the arrow. So that less than or equal to will turn into greater than or equal to. So we will have -9, -8, -7. Open or close circle. Close and shade to the... Oh, sorry. We flipped it. We're going to shade to the right. Sorry. Number 3, we're going to practice solving. We got to solve and then graph. What do I do to solve? Divide by -6. But because I'm dividing by a negative, what am I going to do? Flip the sign. So I usually circle it or highlight it so that I can check to make sure that I did actually flip it. So you should have X is less than or equal to -3. So I'll have -4, -3, -2. Open or close circle. Close and shade to the left. And then last, we're going to solve for X. So I need to subtract 2 first. -12 is 10 is greater than or equal to -x. I need x by itself. So then my next step, divide by -1 to get rid of that negative. But I'm dividing by a negative, so I have to flip the sign. And it'll be a -10. This would be fine, except for I cannot graph in the direction of the arrow, so we're just going to flip it around. So what will it turn into? X is greater than or equal to negative 10. It's also important to know part of the test is multiple choice, so you would need to be able to flip that around in the event that it was multiple choice. Open or close circle, closed, and then shade to the right. To the right. Questions about inequalities? I will tell you there's an entire section of inequalities. We good? Okay. We're going to talk about the midpoint formula. I'm going to show it to you and then explain it to you. So what do we do to find the middle of the x's?
You find a number like in between like the x coordinates.
Right. I meant the formula. How would you find the middle between two numbers?
Oh.
How do you find the middle between two test scores?
You average them.
You average them. You add them and then
Divide by 2.
that's what you do to the x's. You add them together. Divide by 2. That's how you find the middle of the x's. Some people use the formula. Some people just figure out what number's in the middle. That's fine. This is the mathematical way to find the middle of the x's. You do the same thing to the y's. You add the y's and divide by 2. And that's how you find the middle of the y's. All right, the distance formula is a large radical. Go and draw your large radical. It's 2 sets of parentheses. And then what are the signs? Minus, plus, minus makes a weird looking face. Also, what's happening to the parentheses? They're being squared. You're going to take the x's and subtract them. Take the y's and subtract them. So x1 minus x2, y1 minus y2. All right, you need to know when to use it, because it doesn't matter if you've memorized it if you don't know when to use it. But you use it to find the length of a diagonal line. I would probably highlight that so you can figure it out later. You use it to find the length of a diagonal line. Yeah, he needs a pencil. He's struggling. I was trying to look for him. All right, the next section is about segment bisectors. Segment bisectors do what to a segment?
They cut it in half.
Cut in half. So we're going to highlight the 3 segment bisectors that cut these segments in half. We are also going to name them. So the first one, is it a line, ray, or segment? It's a ray. So what do I do to name a ray? An arrow pointing to the right. And then my first letter would be M and then T. So that's that segment bisector. The second one is not a ray, it is a line. The 2 ways to name a line are to put arrows and 2 points, or to write the word line and use a lowercase letter. Which one is going to work for this picture? A line in a lowercase letter, that lowercase m up here. You cannot, because you don't have 2 points. You only have point M, like the capital M. This is a lowercase. It's the name of the line. Good question, though. And then number 6 is just M, yeah. Point M, whichever one. If you were asked to solve it, because I'm going to guarantee you will be asked to solve it, what do I know about 6x and 2x plus 4? They're congruent. How do I know they're congruent? Because the dashes. If they're congruent, what can I do to them? Set them equal. We're not going to solve, just reminding you that in this section you would set them equal. That is 1.3. When you're ready, turn to the next page. I forgot to graph on your paper. I'll pause for a second. All right, so we're going to do the perimeter section first. So what do we do to find the perimeter of any shape?
So you count all the units on each side.
Yes. In other words, we're going to add the sides. So, we're going to do this rectangle first. What is the length of the top and the bottom? The top and the bottom is 2 and 2. And then the length of the sides, 3 and 3. So then we would add 2 plus 3 plus 2 plus 3, which makes 10 units. So perimeter is always in units because it's a length. So you'd say 10 feet, 10 yards, something. All right, the second is a triangle. So what's the length of the bottom? Starts at 2, 1 and goes to 6, 1. So they're four apart. And then starts at 6, 1, goes all the way up to 6, 6. So that's 5. What do I do to find the length of the diagonal line? The distance formula. What a time to be alive. Minus plus minus. You're stressing me out with the highlighter. All right, so you plug in the first x first. What 2 points am I plugging into this? 2, 1, and 6, 6. Yep. So my first x is 2. So 2, I plugged in this 2. And then my second x, 6. So I plugged in my first x, my second x. Now I'm going to plug in my first y, 1. And my second y is 6. All right, so what is 2 minus 6? Negative 4. And then 1 minus 6, negative 5. And then we're going to square. What is negative 4 squared? 16. Positive 16. And negative 5 squared? 25, which makes the square root of, which is 6 point something? 6.4. So then what do I do to find the perimeter all the way around the shape? Add them all up. So 6.4 plus 4 plus 5, which does make 15.4 units. Questions about perimeter? Wonderful news. Area. I'm not going to ask you what the formulas are because it depresses me. The area formula for a square is either side squared, or you could do length times width. Those are the options. They're actually the same thing, because what do we know about a square? The sides are all the same. So isn't length times width the same as side squared if the number is the same? Side times up, yeah. Rectangle is also length times width. A triangle is half of a rectangle. Can we all visually see that it is half? You can literally cut it in half. So it's 1/2. We call it base and height on a triangle. I'll remind you where the base is. The base is not always the bottom, but it will always be horizontal. And the height will never be diagonal. It will always be vertical. So you should like finding the area of a triangle because you're not going to use the distance formula. You just plug it in the formula. This is a triangle, so area equals 1/2 base times the height. So let's find the length of the base. The base will always be horizontal, so what is the length of my base? Starts at negative 1,5 and ends at 5,5.
6.
Correct, it's 6. And then my height, it's always vertical. It's just how tall the triangle is from the very bottom to the very top. So the very bottom, it's at 3,2, and the very top, it's at 5,5 and 1,5. So how tall is it? Correct. It's 3 boxes. 3. Because 2 is 3 away from 5. So 3 is the height. It doesn't really matter what order you multiply in. What's 6 times 3? 18. Half of 18 is. So 9, and we'd say square units. It's because how many squares could we fit inside of the triangle?
2. Or 1.
How many squares can we fit inside of this triangle? 9. That's what 9 square units mean. Question about perimeter area. That's 1.4. Okay. We're almost out of chapter 6. We'll do the angle addition postulate. We're going to do 2 of them and then just set up the next 2 and then move on with our lives. Oops. So this first one, the directions are off to the side on accident. They're supposed to be in this box. We're going to find the measure of angle RST. We know that RSU is 91 degrees. How many degrees of the 91 is already accounted for in this angle? Correct. We already have 69 of it, so how do I figure out how much is left for RST? Subtract. So 91 minus 69 is 22. 22 degrees. Number 2, we got a straight angle. Go ahead and highlight that. Let's talk about what that means. A straight angle. What does a straight angle mean to me? It equals 180 degrees. So we're going to take our 2 angles. Take x plus 20. And add it to x. And together they form that straight angle, which is 180 degrees. So we're going to combine like terms. X and x make 2x plus 20. Subtract 20. 2x equals. So then x is divided by 2. 80. So we're going to find the measure of both of the angles. One of the angles was x, so we know it's 80 degrees. The other one was x plus 20, so that one will be 100 degrees, which makes sense because what should these 2 add up to?
180.
180. Perfect. So those are the 2 we're going to work out. The bottom 2 we're just going to talk about. What is the most important word in this bottom left corner? Bisect. Go ahead and highlight it and circle it. It means the angle was cut in half. So what we're going to do is set the inside angle equal to the inside angle. Because if the outer angle was cut into 2 perfect halves, the 2 halves equal each other. So anytime you see the word bisect. So we're going to take 4x minus 10 and set it equal to negative 3x plus 130. You would solve, you would plug it in, just like before. You what? It isn't negative. And then the last one, are these 2 angles equal? Are they equal? If you were offered the best cake of your entire life, and you were offered this piece and this piece, were they equal? They are not. Okay? But what do we know about the outer angle?
Oh, that's what you're on.
It's 90 degrees. That's what that box means. So we're going to add the insides, and they will equal 90 degrees. So x plus 15 plus 5x plus 57, and they equal 90. Again, you would solve for x, and then you'd plug it back in. When you're ready, we're going to turn to the next page. These are just terms. They're introduced in chapter 1, so that's why they're here. What does complementary mean? They add up to 90, and then supplementary means they add up to 180. We're just going to highlight where the vertical and linear pair angles are. So in comparison to 63 degrees, where is the vertical angle? Y plus 23. Go ahead and highlight them. And then for a linear pair, in comparison to 63, which of these is a linear pair with 63?
2x plus
2x minus 17. Those are a linear pair. That's all we're doing on this page. The next page. These are terms. I'm not going to fill in the blank. You can do that later if you wish. But just knowing what perpendicular is, how do I know when two lines are perpendicular? What do I look for? The box. So you can highlight the box. How do I know when two lines are parallel? The little arrows. Go ahead and highlight those. In 2.3, you have to look at a diagram and tell me what's correct and what's not based on the diagram. So you want to be looking for those things. For a midpoint, how do I know that M is the midpoint? Because of the dashes. Not because it looks like it's in the middle, but because those dashes tell me that M is in the dead center. And the same thing over here. The dashes tell me that that segment was bisected. Vertical angles are blank. Congruent. They are congruent. What's vertical with 50? X. So that means x equals 50. Whereas linear pairs, they're not congruent, they are supplementary. They are supplementary. So which angle is supplementary with 50? Yeah, 50 and y. 50 plus y equals 180. So then y would equal 130. Chapter 2 had algebra in it, but I feel like we do that a lot in the midterm packet. So whenever you're ready, turn to the next page. Chapter 3 is the last thing we're doing today. All right, we're going to highlight which ones are congruent on the top. So which angles are congruent with 1? 4. What else? 5 and 8. If you have a second color, you can always highlight 2, 3, 6, and 7. All right, corresponding angles are blank. Congruent. Corresponding angles are in the same spot at their intersection. So top left, bottom left, all that stuff. That's why they have to be congruent, because they're in the same spot. So angle 1 would be corresponding with angle 5. They're both in the top left. Angle 2 and angle 6. Angle 3 and angle 7. And last, angle 4 and angle 8. Those are all corresponding with each other. Same spot at their intersection. Alternate interior angles are congruent. Interior of what? The double lines, yeah. So what two angles are going to be alternate interior? 3 and 6. And then 4 and 5. Consecutive interior are supplementary. So what is an example of consecutive interior? 3 and 5. That means if you took angle 3 and added it to angle 5, they equal 180. Then the same thing if you took 4 and 6. They add up to 180. And then last, alternate exterior angles are congruent. So examples of that would be
1 and 8.
1 and 8. Then the last example, 2 and 7. Perfect. So that's transversals. You will have to solve for some. You'll need to know which ones are congruent. The last section that we do, I would say, is a very important section. There's a matching section about slopes. There are a couple of equations of the lines like they look like on the back of this page. We'll do chapter 3 and then we are finished for the day. So to find the slope between 2 points, there is a slope formula and it looks like this. M equals, because M stands for slope. You're going to do y1 minus y2. And then x1 minus x2. I would remember that because there are a couple where you have to find the slope. What do we know about parallel slopes? They're the same slope. Good. And then what do we know about perpendicular slopes? They're not the same. Good. So they're opposite sign and they're flipped. Opposite sign. And we're talking positive, negative. And then you flip it. I can do 2 examples. Let's do 7/8. What would 7/8 be perpendicular to? Negative 8/7. And then what about negative 5? That would turn into 1/5. Where'd the 1 come from?
Because it's like understood.
It's understood under the 5. Yep, so that's what it means by opposite sign, and you flip it. In order to know the slope of a line, it needs to be written in slope-intercept form, which means you can see the slope and the intercept. That looks like y equals mx plus b. So when it says find the slope of these lines, they need to be written in y equals mx plus b to find that slope. Which of these letters represent slope, y, mx, or b? Nope. M stands for the slope, just like it stood for it up here. So, is the first one written where I could figure out the old slope? Yes, what is it? 2. I don't have to do anything there. The second one, however, it's not written in y equals mx plus b, so we need to solve for it. What should I move first? The 3x. Can I subtract a letter from a number? Cannot, so I'm going to write them next to each other. The only thing I care about this is the slope, right? I'm going to divide by negative 8. Divide each piece by negative 8. What is my slope going to be? 3/8. Where'd the negative go? Yeah, it's a negative over a negative, which makes a positive. So 3/8 ends up being my slope. All right, and then last we have x equals, perfect, 6y minus 4. So what do you want to move first to solve for y?
6.
You can do that too. There's many ways to solve this problem. There's so many ways to solve this problem. It's fine. So they want to add 4. We can do that. Can I combine 4 and x? No, so I'm going to write them next to each other. So x plus 4 equals 6y. What is my next step?
Divide by 6.
Divide by 6. Divide each of them by 6. So you have y by itself. You have x over 6. And that reduces to 2/3. But like I said, we only care about the slope. If this bothers you, you can always, flip them. You could write the y first, then the equal sign, then the x over 6 plus 2/3. What number is invisibly in front of the x? A 1. So what is the slope of this line? 1/6. There's the 1, there's the 6. This next one we need to find the slope. What does the slope formula look like?
M equals y1 minus y2.
Perfect. It's y1 minus y2 over x1 minus x2. So what's my first y? 8. My second y? Well, it's negative 6, and when I plug it in, there's a negative in the formula, which does make a plus. Correct. And then my first x and my second x is 4. 8 plus 6 is? Minus 5 minus 4? Negative 9. Can this be reduced? Nope, that's just the slope. That's it. The last page. This is it. Go ahead and write in the points. For some reason, they're not written there. 3, 4, and negative 9, 2. 3, 4, negative 9, 2. You have an abundance of room. I do not. So at one point, I have to erase what we did so that I have room. But when writing an equation of a line, there are 3 steps. The first one is to find the slope. First one is to find the slope. Second one, you're going to plug in the point and the slope. And you'll plug it into y minus y1 equals m times x minus x1. This is called point-slope formula, where you plug in your point. I highlighted in red where you plug in the point, and highlighted in blue where you plug in the slope. And then, what do we want every single answer to look like? And we solve for y equals mx plus b. And that's what we want our final answer to look like. So first, we have parallel and perpendicular. What do we know about parallel slopes? We want to find the slope. Parallel slopes are the same slope. Do I know the slope of the old line right now? No. It's not written in y equals mx plus b. So we need to write it that way first. So we're going to add x. So 2y equals x minus 9. Divide by 2. So what is my old slope? 1/2. That 1 came from right in front of the x. There's an understood 1. My old slope is 1/2. What's parallel to 1/2? 1/2. So we're going to plug in. We're at step 2. Plug in a point and a slope. There's my point. There's my slope. We're going to plug it into point slope. I don't have room to do that unless I erase. So y minus y1 equals m times x minus x1. So what is my y-coordinate? 4. My slope is 1/2 still. And then my x-coordinate is 3. We're going to distribute. We got y minus 4 equals 1/2 x. And then 1/2 times negative 3. What do I do to multiply a fraction by a whole number? Put it over 1. Go across. 1 times negative 3 is negative 3. And then 2 times 1 is 2. So I'm going to put the negative in front. Makes negative 3 over 2. And then my last step, add 4. So in order to add them, so we're trying to add these two, we have a fraction and a whole number. What does the whole number need to be over? It needs to be over 2, and it's over 1 right now. So what am I going to do to this fraction? Multiply the top and the bottom by 2, so that the denominator will become a 2. So the first fraction I'm going to leave alone. I just dropped it down. The second one will become 4 times 2, which is 8, and then 1 times 2, which is 2. 8 over 2 is equivalent to 4, isn't it? So that's good. We still added 4 to both sides. We just made it look different. So now we just combine our like terms. We got y equals 1/2 x. And what is minus 3 over 2 plus 8 over 2? 5 over 2. We have one more, and then we are done. We want perpendicular to this line. So again, step 1 is to find the slope. Is this written where I know the slope? No. So what do I need to move first? The x. So I'm going to subtract it on both sides. Can I subtract a letter from a number? Cannot. Just going to write them next to each other. And then divide by 4. So we should be able to tell what our slope is without even reducing the last bit. What is our old slope? Negative 3 over 4. But I want perpendicular to negative 3 over 4. 4 over 3. So we're going to use 4 over 3 as our slope. And we're going to use negative 9, 2 as our point. So once we got our slope, we're going to plug in 2y minus y1 equals m times x minus x1. The y-coordinate, 2. We said our slope is 4/3. And then our x-coordinate is at negative 9. When I plug in that negative 9, it will turn into a positive. Distribute, we got 4/3 x. Then we want to do 4 over 3 times 9, right? Times positive 9. Put it over 1. So yes, sorry, I heard what you said. 4 times 9 is, and then 3 times 1 is, this reduces to 12. Is it a positive 12 or a negative 12? Positive. And then our last step, we're going to add 2. So then y equals 4/3 x plus 14.